I'm going to work through solving this system of equations and show how to do it with the matrices, the Gauss-Jordan elimination, where your goal is to get ones on the diagonal and zeros everywhere else on the left side. And there were a few typos, I think, here. I'm going to be solving this. You have minus z, but down here you wrote a 2. It should be a negative 1. And here you have minus y, and down here you wrote a negative 4. Again, it should be negative 1. So again, before I get started on solving this, there's 3 row operations that we can do in order to get the ones on the diagonal. You can switch any of the 2 rows, and you don't often get to do that, but it's a very, very easy thing to do. You just reorder the rows, and you only want to do that if that'll help you get ones on the diagonal. So if it's ever the case where you have a situation like this, if you wanted to get ones on the diagonal, to get a 1 in this top spot, the easiest thing to do is just switch row 2 and row 3. And so this whole thing would become the second row, and this would be the first row, and that would put the 1 right up there on the diagonal. Most of the time you'll be using operations 2 and 3, where you either multiply a whole row by any non-zero number. And here it says multiply both sides of an equation. That's basically a different way of saying multiply an entire row. When you have that augmented matrix, you're putting both sides of the equation in a single row. So multiply the row by any non-zero number, or add any 2 rows together. And you can add the sums of the rows. So you could do like 2 times the first row plus 3 times the second row, but you're adding the 2 rows together. So let me go through with how to solve this, and let's see. Here we go. So here's the matrix in augmented form, and our goal is to get ones down the diagonal. So we're going to start with the top left. How do I change this to get a 1? I'm going to multiply the first row by 1/2. So everything in the first row by 1/2, and now I have a 1 there. So then your secondary goal, once you get a 1 in the spot, is you want to get zeros in the rest of column 1. So we got a 1 where we wanted it, now we got to 0 out the rest of the column. So how am I going to 0 out this second row? I'm going to add some rows together. So I'm going to do negative 2 times this first row, because negative 2 and 2 will equal 0. So negative 2 times this whole row and add it to the second row. And I chose negative 2 because my goal is to get a 0 there. So negative 2 times 1, add that to 2, you get the 0. Negative 2 times 1 here is a negative 2, add another negative 1, you get negative 3. Negative 2 here gives you a positive 5, add the 1, you get a 4. Negative 2 here gives you a positive 5, add the 5, you get a 10. And I didn't change row 3 at all. So now I want to get a 0 in this next spot. And I'm going to do 4 times row 1 plus row 3. So I chose 4 because 4 times this, 4 times 1 plus negative 4 gives me a 0. 4 times that gives you a 3 when you add. 4 times that, you would get, what would you get there? Negative 10 plus 10 gives you a 0. And again, negative 10 plus 0 gives you a negative 10. So one thing to notice is once you get that 1 there, the easiest thing 99% of the time is to always multiply that row by the number you want in order to 0 out the rest of the columns. Because it's a 1 there, it's really easy to identify what number to multiply by in order to cancel out with the 2. Like I need to multiply 1 by a negative 2 in order to cancel out the 2. I need to multiply 1 by a positive 4 to cancel out the negative 4. So start by getting the 1 in the spot on the diagonal, and then multiply that row by what you need in order to add it and cancel out the rest of that column. Alright, so there you have that first column, looks good. and just moving down, you want to get a 1 in the next spot on the diagonal. So the next spot on the diagonal is right here. We want a 1 there. And we're just going to multiply this whole row here by a negative 1/3, and we get a positive 1 there. And we're going to do that same thing. So we want to multiply this row now by the numbers needed to zero out the rest of column 2. So since we got a 1 there, it makes it easier to spot what to multiply by. We don't need to multiply by any, we need to multiply by a negative 1 to cancel out with this value. So you add these first things, nothing changes because 0 plus 1 stays the same. Negative 1 plus 1, you got to cancel. And here you got to do a little fraction math. But negative 1 plus that, you get negative 7/6. And negative 1 plus that, you get positive 5/6. And now we need to cancel out this 3, so multiply by a negative 3. So everything here by a negative 3. Negative 3 plus 3 cancels out. These are kind of nice. Negative 3 just cancels out with the denominator here, so you get a positive 4. Positive 4 plus 0, positive 4. Again, negative 3 cancels the denominator, so you get positive 10 plus negative 10 gives you a 0. And now you're done with that second column. So our goal now is to move right down the diagonal and get 1s in the next spot. And let me go ahead and hit enter here a few times so you can get everything on the same screen. Okay. So we have a 4. If we multiply by 1/4, we'll have a 1 there. So the whole row by 1/4, the rest of the row is 0, so nothing really happens except that changes to a 1. So our diagonal looks good. And now if we zero these out, we'll have our answers. So get zeros in the rest of column 3. So what do we have to add, or what do we have to multiply this to cancel out with negative 4/3? Multiply by a positive 4/3. Positive 4/3 plus negative 4/3 equals 0. And then nothing else happens because positive 4/3 times 0 is just 0. So that stays the same. Times 0, that stays the same. 4/3 times 0, that stays the same. So the only value that changes is we get that 0 where we wanted. And same with the next item. Get rid of this negative 7/6. We need to multiply by a positive 7/6. And again, the rest of the row is 0, so nothing else is going to change besides 7/6 plus negative 7/6 gives us a 0. And so now you have the identity matrix over here. And these are your solutions for x, y, and z. And you can plug those back in. If you plug this value in for x, this value in for y, and this value in for z, all 3 of these equations will be true. So you can kind of test your work. So I'll send you this website. Also, there's another website. You obviously need to know how to work this out on your own for the final exam and to understand the concept. But if your calculator doesn't do these, there's a website where you can just type in the x, y, and z. It's a little clunky, but you type in your x, y, and z and then your augmented part, and it'll solve it for you so you kind of know what you're working for. And you can catch yourself if you get an error before you enter it in MathLab. It doesn't really show the steps, which is a little bit of a bummer, but it does show the answer. So if you mess up somewhere along the way, you can go back and try to catch yourself before it gets counted wrong in MathLab. But I guess in closing, there's a lot of steps here. These are kind of long problems. So really go slow, and I encourage you to write down step by step what you're doing. And step by step, one step at a time, change just one number at a time. Then if your answers looks wrong or you need to go back and change something, you know exactly what you did, and you can go back and verify that you did this step correctly. And then you can say, okay, that nothing's wrong there. Let me check that I actually multiplied everything by the -2 correctly and added everything correctly. A lot of times the mistake is adding negative numbers incorrectly, messing up a sign somewhere, or if you're multiplying by -2, you forget to multiply everything by -2. So really take your time on these, and let me know if you have any other questions.